Alright, hi guys. This video should be pretty quick. We are talking about properties of logs and evaluating logs. Sorry about the handwriting, I'm getting used to this new system here. So first of all, we have to go through our 5 new properties of logarithms that we're going to learn. So the first one is log base a of a to the k equals k. So sorry, I'll undo that, make that a little more clear here. Equals k. So basically what this is saying is that since logs and exponentials are inverses of each other, if we have a log and an exponential with the same base, those are going to undo each other and we're just going to be left with what's in the exponent, that k value. This works the other way as well. A to the log base a of k equals k. This is the same thing. That first property is a log composed with an exponential, and the second one is an exponential composed with a log. Both of them are going to undo each other, and we're just going to be left with k. The next property is that log, bear with me, log base a of 1 equals 0. So that means that log base anything of 1 equals 0. If you're taking the log of 1, no matter what the base is, natural log, common log, base 5, base 15, base 3, whatever, that's going to equal 0. Our next property is a really important one called change of base. So I'm actually going to label it change of base. And that is that log base b of a equals log of a over log of b. So what's really nice about this is that if we have log with a base of something that we can't do in our calculator, a really strange base like base 11 or base 13 or something like that, we can change it to be common log of what we're taking the log of. That's called the argument. The a is called the argument. Common log of a over common log of b. So we'll have common log of the argument over common log of the base. We'll see a couple examples of that down below. And then our last property is called the power rule. Goodness. And the power rule says that if we have log of a to the k, that equals k log of a. So what we're saying there is that if we have log of a, log of anything, to a certain exponent, we can pull that exponent out front and multiply it. Alright, so let's try evaluating a couple of these. Log base 3 of 6. I have no idea what that is because I don't know what I need to take 3 to get 6. If I take 3 to the second power, it's already 9, so it's too big. So we can use our change of base formula here. So this is going to equal log of 6 over log of 3. And that we can just type right into our calculator. So I type in log 6 divided by log 3. And we can see that equals 1.631. That should probably be an approximated equal sign. Okay, let's try the next one. Log base 12 of 168. Same thing. I have no idea what I need to take 12 to get 168. If I take 12 squared, that gives me 144. But as soon as I cube 12, I get 1,728. So it's somewhere in between 2 and 3. So I can just type this in. And what's nice about change of base is that we can do natural log as well. So I can do natural log of 168 over natural log of 12. Log or natural log will get us the same answer, as long as we do it the same for the numerator and the denominator. So that one is approximately 2.062. Alrighty, natural log of 29. This one's nice because I don't even need change of base. This one I can literally just type directly into my calculator. Natural log of 29. And that's going to be approximately 3.367. I know this might seem a little bit trivial at times, but this is going to be on our homework where we just have to evaluate logarithms. Log of 18, that's another one that I can just type right into my calculator. And that's going to give me approximately 1.255. Hopefully you guys are practicing typing these in yourselves and making sure we're getting the same answers. This next example, I can see I have a log and an exponential with the same base, 5 and 5. Those have the same base. So those are going to undo each other, and I'm just going to be left with 2.7, that exponential. Same thing on this next example here. I have base of 7, base of 7. These are composed the other way where I have an exponential composed with a log, but once again, those cancel out and I'm just left with root 13. Same thing here, base of 6, base of 6. Undo each other, I'm just left with n minus 4, whatever that n may be. This one is kind of unique to recognize, but we want to see that e and natural log are in fact the same base, because remember that the base of natural log is e. So those undo each other, we're left with 2. Remember I said log base anything of 1 is 0. Same thing here, log base anything of 1 to the whatever is still 0. It doesn't matter what that exponent is, it's still going to equal 0.